Question from October-November 22, 9709, variant 31. Question number 5. The complex number u and w are defined by, so two complex numbers u and w are given in the exponential form. Find u square over w, giving your answer in the form r e raised to the power I theta, means exponential form. So u square over w. U is 2e raised to the power 1 over 4 pi iota power 2 divided by W is given 3 e raised to the power 1 over 3 pi iota. Simplify the numerator. 2 power 2 is 4 and multiply the powers. So when you multiply the powers, so we have e to power 1 over 2 pi iota whole divided by 3 e raised to the power 1 over 3 pi iota. Next is 4 over 3 e raised to the power 1 over 2 pi iota minus 1 over 3 pi iota. When you simplify 4 over 3 e raised to the power, so you take LCM of the numerator, LCM of the power of e. So this is 1 over 6 pi iota. So u square over w is here 4 over 3 e to power. So this was the required form. So write the answer of the complex number u square over w in the form r e power iota theta, and yes, this is there. The second part is find the least positive integer n such that imaginary part of w power n is 0 and real part of w power n is positive. So w we know is w is here 3e to the power 3e raised to the power 1 over 3 pi iota. W power n would be 3e raised to the power 1 over 3 pi iota whole power n. When you simplify, it is w raised to the power n is equals to 3 to power n e raised to the power e raised to the power n over 3 pi iota, which you can further write 3 power n cos of n pi over 3 plus iota sine n pi over 3. Because we know that e power iota theta is cos theta plus iota sine theta. The real part, the imaginary part is 0. So what is the imaginary part? Imaginary part is, so when you open the bracket 3 power n cos n pi over 3 plus 3 to power n iota here and sine of n pi over 3. So imaginary part of w power n is equals to 0. This is the condition given. So 3 raised to power n cos of n pi over imaginary part, which is sine. Sine n pi over 3 is equal to 0. Sine of n pi over 3 is equals to 0. So this is sine of angle equals to 0. If you just recall the graph for the sine, this is the graph for the sine. So 0 here, pi here, and 2 pi here. So n pi over 3 can be 0 or pi or 2 pi. So from here, n can be 0, when you equate n pi over 3 to this pi, it is 3 and then 6 when you equate this to the last. So as n is positive, so reject this option because 0. 3 and 6. So after using this condition that imaginary part of w power n is equals to 0, so there are two possible values for n. Now we'll verify these two values of n for the second condition. The second condition is also given. So let's verify. So the real part of w power n is here. This is the real part is equal to 3 raised power n. It has to be greater than 0. So 3 cos of so this is greater than 0. I can write on this side. Also given that real part of w power n is greater than 0. Real part is 3 to power n. Cos of n pi over 3 is greater than 0. Cos of n pi over 3 is greater than 0. So we'll verify these two here. So if n is equals to 3, let us check whether this is true or not. This would be cos of n is 3, so 3 pi over 3 means pi. So this is minus 1 greater than 0. So this is false. So reject this option again. Next option is n is equals to 6. So if n is equals to 6, let us verify it here. This would be 6 pi over 3 means 2 pi, and cos of 2 pi is equal to 1, so greater than 0, which is true. So hence the smallest positive question was find the smallest positive integer n. So the smallest positive integer is n. Therefore, the smallest positive integer for this part is n equals to 6. So here is the step for verification. The approach is simple. First, I converted this complex number in the simple in the modulus augment form, and this is w raised to the power n coming as 3 power n, and this is the from here you can easily identify real and the imaginary part. First, I started with the condition that imaginary part of w power n equals to 0. So I used this condition, and as a result, I obtained answers for n, 3, and 6. Then I verified. Then there's a step of verification, and this verification is in the other condition. So first I wrote the other condition, and then I used the real part here, and eventually this is the inequality which we are obtaining. So this must be true for that value of n. So this is the inequality which we are obtaining here. So then first I use the number n equals to 3. For this, the answer for this left-hand side is coming minus 1 and greater than 0. So this is false. So reject this option. And the second is n equals to 6. And this verified, and so with the answer that n equals to 6. Thank you.